In the year 1977, while the world witnessed the dawn of the personal computing revolution and the final Viking landers touched down on Mars, a quiet yet profound moment in history unfolded. Voyager 1 was launched into the vastness of space. Originally designed with a modest mission to study the gas giants Jupiter and Saturn, this spacecraft would ultimately redefine our understanding of the cosmos. What began as a planetary tour soon evolved into an unprecedented voyage through the outer reaches of our solar system and beyond. Now, nearly 5 decades later, Voyager 1 floats an astonishing 23.5 billion kilometers away from Earth. It has traveled farther than any human-made object in history, becoming a silent ambassador of Earth, a time capsule carrying humanity's voice, vision, and curiosity into the great unknown. Its journey has not only rewritten textbooks but also challenged some of our most deeply held assumptions about space and our place within it. One of the most surprising discoveries came when Voyager 1 reached the edge of our solar system, the so-called heliopause, a region where the solar wind meets the interstellar medium. Scientists once believed that the Sun's magnetic influence faded completely at this boundary. But Voyager 1 shattered those assumptions. It detected magnetic fields that did not simply vanish but instead tangled and intertwined with interstellar forces. This hinted at a dynamic interaction between solar and galactic magnetic systems, revealing that the cosmic frontier is far more complex than once imagined. This unexpected magnetic dance has critical implications. The strength and behavior of these magnetic fields affect how cosmic rays, high-energy particles from exploding stars and black holes, penetrate the solar system. Near the heliopause, Voyager recorded bursts of cosmic rays 1,000 times stronger than those near Earth. This revelation underscores a serious concern: our heliosphere, the invisible shield surrounding the solar system, may not be as protective as we thought. This has major consequences for future space exploration, especially long-duration missions to Mars and beyond. To protect astronauts from this DNA-damaging radiation, engineers are now exploring advanced shielding technologies like magnetic deflectors and active plasma barriers. But the surprises didn't stop there. Voyager 1's plasma wave instrument picked up something no one expected: dense plasma clouds, scattered throughout interstellar space. Models had predicted a smooth, uniform interstellar medium. Instead, Voyager encountered wildly fluctuating plasma densities, some more than 40 times greater than anticipated. These discoveries paint a picture of interstellar space as a turbulent ocean, stirred by ancient supernova shockwaves and the stellar winds of dying stars. Future spacecraft must be built to withstand such hostile environments, sparking new priorities in materials science and engineering resilience. Even the very structure of the heliosphere, once believed to resemble a long-tailed comet, has been called into question. Data from Voyager and other missions suggest that our solar bubble may be asymmetrical, irregular, and porous. If true, this would further diminish its shielding power and could explain why some cosmic rays slip through more easily than predicted. This has triggered a push for better space weather forecasting and enhanced radiation protection for both satellites and astronauts, ensuring that Earth's technologies and space missions can withstand cosmic threats. Among Voyager's most poetic contributions are the eerie, otherworldly sounds it has captured, plasma waves converted into audio files. These songs of interstellar space include haunting hums, high-pitched whistles, and ghostly echoes that change with solar activity. For scientists, these vibrations are more than sound, they are a sonic fingerprint of the universe's hidden dynamics. For the rest of us, they offer a surreal and emotional connection to the cosmos, blending cutting-edge science with profound wonder. Voyager's longevity is powered by a remarkable piece of technology, its radioisotope thermoelectric generator, or RTG. This device converts the heat from decaying plutonium-238 into electricity. While the power output decreases by about 4 watts each year, mission engineers have extended the spacecraft's life by shutting down non-essential systems, including the cameras that once captured breathtaking images of our planetary neighbors. Today, only 3 scientific instruments remain active, still collecting vital data on cosmic rays, plasma, and magnetic fields. By 2030, even these last whispers will fade, and Voyager 1 will continue its voyage in silence, a ghost ship adrift in the galactic sea. And yet, even in its silence, Voyager will continue to speak for humanity. On board is the famous Golden Record, a phonograph disc encoding the sights and sounds of Earth. Curated by a team led by astronomer Carl Sagan, the record contains 116 photographs, ranging from mathematical equations to scenes of everyday life on Earth, alongside 90 minutes of music from cultures around the world. From Senegalese drumming to a Bach concerto, it is a message in a bottle for any intelligent beings who might one day find it. Etched into the record is a pulsar map showing Earth's location in the galaxy, an inclusion that has sparked debate about whether we're truly ready for contact with extraterrestrial civilizations. Still, it stands as a bold gesture of openness, a reflection of our desire not just to explore, but to be known. Designed to last 1 billion years, the record may outlive humanity itself. Perhaps Voyager's most iconic gift is the pale blue dot photograph. Taken in 1990 from over 6 billion kilometers away, the image shows Earth as a tiny speck, just 0.12 pixels, suspended in a sunbeam beside the rings of Saturn. Carl Sagan's famous words echo through time, "Look again at that dot. That's home. That's us." The image has become a timeless symbol of planetary unity, reminding us that our divisions are trivial in the grand scale of the universe. Voyager 1's mission is far from over, it continues to inspire. NASA's upcoming Interstellar probe, planned for the 2030s, aims to follow in Voyager's footsteps, armed with more advanced sensors and propulsion. Meanwhile, private initiatives like Breakthrough Starshot envision fleets of tiny laser-propelled probes racing toward Alpha Centauri. These missions stand on Voyager's shoulders, building on the lessons learned from its endurance, its discoveries, and its spirit. Yet, the journey has also exposed challenges. Communicating with Voyager is a slow and delicate process. Its signals, traveling at the speed of light, take over 22 hours to reach Earth. The data rates are glacial, just 160 bits per second, slower than early dial-up internet. Still, each bit contains priceless information, arriving through NASA's deep space network like a whisper from the edge of forever. Voyager 1 is more than a spacecraft, it is a symbol of our species' unyielding curiosity. It has journeyed from a planetary scout to an interstellar pathfinder, defying the limits of age, distance, and imagination. Its mission teaches us that exploration is not about finding quick answers, but about embracing the unknown, asking bigger questions, and daring to keep going even when the path is uncertain. As its final instruments dim and it sails deeper into the galactic void, Voyager leaves behind a legacy that will echo through the ages. It reminds us that mystery is not something to fear, but to pursue. That the universe, vast and ever-changing, invites us to continue reaching, questioning, and dreaming. So, as Voyager 1 drifts onward into the stars, let us remember what it represents, the best of what it means to be human. Thanks for watching. And if you're as fascinated by space exploration as we are, don't forget to like the video and subscribe for more awe-inspiring journeys through the cosmos.